Hey everybody. Today we're going to jump into lesson 5.2, which is multiplying rational expressions. Shout out to all the people that I used to teach in Ohio who just got a notification on their YouTube and have no idea why. If you were checking this, shout out to you. Anyway, let's jump right in here. Yesterday we were practicing how you can factor trinomials, turn them into binomials, and then start canceling some things out. Today we're just going to take that to the next level, and we're going to multiply. Now, quick little note here, please don't write this down, I just want to show it to you real quick. If somebody told you to do 1/3 plus 3/4, you would not be allowed to cancel the 3's. Okay, a lot of people think they should, but you can't. It's just like if you were to look here, you can't just cancel this x squared and this x squared, because that idea, that concept doesn't work with addition and subtraction. However, it does work with multiplication. So if somebody were to give you 1/3 times 3/4, and you're like, well, the 3's cancel out, the answer is 1/4, you would actually be right. So that's the idea that we're going to work with today. All right, so let's go through this problem. Let's try to do it the right way here, kind of using what we just talked about as a guide. If we can factor, and as we factor we can find things in common, we can cancel them out. The biggest key to this whole thing is that you have to do something on top with something on bottom. Okay? So I'm not going to spend a lot of time talking about how to factor. I think for a lot of you, it's going to have a lot more to do with just remembering what you used to do, what you used to practice. Remember, we're looking for two numbers that multiply to give us the last number and that add to give us the middle number. Okay, so that's where we're at right here. Now, this particular part, the upper right, it's actually going to factor two different ways. The first thing I noticed was that there's a 2 in common. So before I do anything at all, I'm going to have to take the 2 out, and then it would factor the rest of the way. Now, at this point, maybe you noticed this, maybe you didn't, but what we actually had here, after you took the 2 out, we had the exact same thing on top as we did on bottom. So again, not sure if you noticed it or not, but there it is. So when we start figuring out what cancels out, you can pretty much say, well, I've got this on top and this on bottom, so that can go away. I've got this on top and this on bottom, so it can go away. And what that leaves me with, everything on the right side went away except for the 2. So that would mean my final answer, if I multiplied straight across, I would get 6x squared here, and then the last two factors on the bottom were the x plus 2 and the x minus 4. Now you could multiply them back through, you would end up getting this again, but there's no real need to do that. So I wouldn't bother. It's not going to get you any closer to a right answer. It's not going to be more right or anything like that. All right, now, yesterday we did cover one other concept. It was called excluded values. I talked about it like it was the notifications on your phone. You know, we get these notifications all the time for things that we didn't even care about, we didn't even like. That's how I think about these excluded values. It's just putting out a little notification that, oh, by the way, x cannot be this, this, or this. Basically, anything that would cause the denominator to equal 0 has to be thrown out the window, because if the denominator were to equal 0, you would have something undefined. So I'm going to look back at the original factors, as in this right here. What would make x equal 0? Well, if it says x plus 2, then that means negative 2 would make it equal 0. Same thing with the x minus 4, and same thing with the x minus 5. So those are my excluded values. You definitely want to make sure you throw them in there. All right, let's go over here. Let's start with the upper left. The only thing I can do on the upper left is factor out an x. There was not a whole lot there, which is sort of aggravating, but that's okay. All right, now we go over here. That 14 is pretty much stuck, but that's okay. We can work with that. We're going to get x plus 3 and x plus 5 because, again, we're looking for two numbers that multiply to give me 15 and add to give me 8. All right, now on the bottom, I've got x plus 8. Not a whole lot there, but a little something might help us out. And then we've got a 7 that we can take out of the upper right. All right, so did that help us? Were we able to simplify this down at all? Looks like we were able to get a couple things. The x plus 5, goodbye, and goodbye. And then as I look, 7 over 14 reduces to 1 over 2. Now, I'm not going to write that 1 as a part of my final answer, but I am going to leave it there just so I don't get confused about what order I want to write things in. When it comes down to my final answer here, I am going to leave what's on top. So in this case, it looks like on top all I've got here is the x and the x minus 8. Now, I don't know if you were tempted to cancel out the x minus 8 with the x plus 8. It is tempting, but you're not allowed. So we're going to go with a 2. The x plus 3 is still there. And then the x plus 8, like I said, it would have been nice if it would have canceled, but it didn't. All right, as we look at the excluded values here, it looks like x is not allowed to equal that, or that. I see x plus 3, so that means negative 3 is off limits. I see x plus 5, so negative 5 is off limits. And I see x plus 8, so negative 8 is off limits. Again, the denominator is what matters in this case. The numerator I really don't care about. If the top equals 0, it's fine. The issue is if the bottom equals 0. All right, let's do one more, and then we will jump to the division step. Looks to me like x squared minus 9, that was one of those difference of squares problems. Basically, what multiplies to give you negative 9 but adds to give you nothing in the middle? You see how there's nothing in the middle? There's no like x term in the middle. That means they have to cancel. That means we're going x plus 3 and x minus 3. Go over here. We go to the bottom left, and it looks to me like I've got an x plus 3 and an x minus 8. There you go. Now we look over here. I can already see something develop here. We've got a lot that's going to cancel. As you look at the bottom right, you can actually take a 2x out of this because both terms have a 2, both terms have an x. And that would actually just leave you with x minus 9. Now, it would be really nice if that said x squared minus 9 because then we could cancel even more out. But in this case, we can't. So we're just going to have to deal with what we got. All right, we look over here. There are going to be 4 excluded values. That's really annoying, but we'll deal with it. And let's cancel some stuff. Right here, and then right here, and right here. I was hoping for more, but I guess we'll get what we get. And we won't throw a fit, just like I tell my kids at home. So let's see what we've got for our final answer. Our final answer is going to have an x minus 3 on top. Nothing on the bottom right canceled, unfortunately. I had high hopes, but I guess it didn't quite work out. And then there are actually 4 things that x cannot be. So 1, 2, 3, 4. So I'm looking at the denominator and I'm looking for all of the things that you could plug in for x that would cause the denominator to equal 0 on any of the fractions. So I found negative 3, 8, 9, and it actually turns out the 4th one would be 0 because if I put 0 in right there, 2 times 0 is 0, and anything times 0 is obviously 0. All right. I'm going to leave letter D to you, and we are going to get to dividing. Now, I'm not going to go over this one right this second, but I do want to go over the basic idea. Whenever you divide with fractions, and you learned this a long time ago, you flip the second fraction, and then you multiply. Okay? So it's going to look something like this. If something reduces, you reduce it. In this case, nothing does, so you are pretty much stuck, and you would just multiply it out. You'd get 56 over 45. But I bring that up because the exact same concept is going to apply with these bigger, uglier problems. What you need to do is leave the first fraction alone. Leave it exactly how it is. Don't change a thing. I know it's going to be tempting to do it, but don't do it. And then you're going to flip the second fraction and multiply. So change that symbol from division to multiplication, and then flip the second fraction. Now, I know it's an extra step to write it out. Do it anyway. Get over it, okay? All right, so we're going to factor. We're going to factor the top left. Now, those of you who are really strong in the math world, you're probably like, Mr. Boone, why didn't you just write it as x plus 7 squared? If our ultimate goal is to try and cancel some things out, then it might not really be a great idea to try to write things out with shortcuts. You're probably going to be better off writing each factor out separately so that if, hypothetically, something cancels out, you are ready for it. So that's what I would do if I were you. If maybe, just maybe, I don't know. Do you think possibly? Yeah, there you go. All right, so we look over here, x plus 7, and you see by writing it separately, what ended up happening is now we recognize that there's still one of them there. Okay, so you're not wrong if you didn't do it that way, but that's what I would do. All right, then we go over here, that cancels. So my final answer, and I'm running out of room for my excluded values, but that's okay. We've got x plus 7 and x minus 1 on top. And then we've got x squared on bottom. Now we are running out of time. So the excluded values, I'm not going to write them all out, but I would be looking for things like -2, -7, 0, that sort of thing would be in the ballpark. All right, let's take a look here. I think we have time for one more. And the first thing I'm going to do, even though it is tedious, get the heck over it. It is tedious here, but I want you to actually go through the process of rewriting the second fraction before you factor. I say that because the concept today is not all that difficult. The issue is not about the concept. The issue is about forgetting to flip the second fraction, and people do that so often, so just don't be that person. Now that we've done that, now that we have flipped the second fraction, we can try working on factoring. There's not a whole lot I can do with the bottom left. I could take out a 3x, which is good enough. That would give me x minus 10 right there. It looks to me like that's actually really going to help us because I also have an x minus 10 on the upper right. There you go. All right, now this particular spot, the bottom right is a little bit trickier. It actually factors two different ways. You can take a 9 out, and then as soon as you have taken the 9 out, then you could factor it a little bit more. I'm going to cut to the chase because we're down to our last minute. It turns out that it's not actually going to help us much, but that's okay. Let's figure out what cancels here. The x minus 10s, that helped us a lot. We also have an x on top and an x on bottom right here that we can cancel out. And 6 divided by 3 is 2. So I'm not going to have time to go over the excluded values. However, I will tell you my final answer is going to have a 2x on top. And then on the bottom, it's going to have pretty much everything we had over there because I was not able to get any more of it out. So anyway, I want you to try the last two examples on your own. Hope this really helps, and I will see you all next time.